Hello guys, welcome back to our channel. So today we're back at it. We'll be discussing work, but first please hit the like button and subscribe. Okay, we'll start off by defining work. Work is done when a force is applied in or against the direction of the moving object. Okay, let's take for an example a box which is at rest, and then we apply a force at it, which is this force at a certain displacement, and then the box moves. This means that there was work done on this box by this force in which we applied. Okay, work can be calculated as follows. W is equal to F delta X cos theta, where W is work in joules and then F is acting force in newtons. In this case, it's this force. And then delta X is the displacement in meters, meaning it's this displacement in this case. And then theta is the angle between force and the displacement. Okay, I would like us to take note of two things. Work can be negative and it can also be positive. How so? When we have a force that acts against the displacement, it means that our work is negative. But when we have a force which goes to the same direction as our displacement, it means that we have positive work done. Let's take, for instance, a gravitational force, which we all know that it's always going downwards with a displacement which is going upwards. This means that right here our work done will be negative. And then let's take another example again of gravitational force which is going down, as we all know, and then a displacement which goes to the same direction as our gravitational force. This right here means that we have a positive work. And then one last thing I would like us to take note of is that when the angle between the force and displacement is 90 degrees, it means that no work is done. For example, work done by a normal force will always be zero. So here is proof to why work done by a normal force will always be 0 joules. I think we all know that normal force is always perpendicular to the surface in which an object is placed on. So meaning that the angle between the displacement and normal force is 90 degrees. And then when substituting in our work formula, which is F delta X cos theta, our theta will be 90 degrees, and I think we all know that 90 cos of 90 degrees is 0, and then when substituting that 0 in our formula, we'll get 0 joules. I have a problem that I would like us to try out. It reads as follows. A 20 kg block is placed on a rough surface inclined at 30 degrees to the horizontal. A constant force F of 116 newtons acting parallel to the surface is applied on the block so that the block moves up the incline at a constant velocity of 2 meters per second. And then it says refer to the diagram below. And then the question says that calculate the work done by frictional force if the block moves for 2 seconds. We'll start off by writing our formula for work done by friction, which is equal to frictional force delta X cos theta. In this case, we have two unknown parameters, which are frictional force and displacement. And then in the first step, when solving such problems, we always draw a free body diagram, even if you were not asked to draw one. So in our free body diagram, we have 5 forces. In the horizontal, we have 3, which is the force F, which was applied, and then we have frictional force, which always opposes the motion, and then we have the the parallel force. And then we have two forces in vertical, which is the normal force and the perpendicular force. The second step after writing down your free body diagram, you write the equation. But remember that the block moves at constant velocity, so the net force will be 0. As written in this equation, F net is equal to 0. And then in the next step, we will substitute with our horizontal forces, which is the negative frictional force and the negative parallel force plus the force applied, which equate to 0. On the next step, we will substitute. We have an unknown, which is frictional force, and then we all know that the horizontal constant of gravitational force is equal to mg sine theta, m being the mass and then g being the gravitational acceleration, and theta is the inclined angle. So after substituting our values, we will get our frictional force, which is equal to 18 Newton. And then in the next step, we will try to calculate the displacement, because it was one of the values which was missing. We'll use the formula which says delta x is equal to initial velocity times delta time plus half acceleration t squared. Acceleration in this case is equal to 0 because the velocity is constant, meaning this part of the equation will be 0. So we'll only use this part, which is initial velocity times delta t. And in the next step, we'll substitute our values. We know that our initial velocity was given as 2 meters per second, and the time was 2 seconds, and then we'll get delta x, which is equal to 4 meters. And then now that we've calculated both our unknowns, we can continue to calculate what was asked in the question, which is work done by frictional force. Work done by frictional force is equal to frictional force times delta x times cos theta, which is equal to 18 of the frictional force times the 4 of the displacement, and then times cos of 180, and then work done by frictional force is equal to negative 72 joules. This shows that work done by frictional force will always be negative because friction always opposes the direction of the moving object. Thank you for watching. So if you have any question, please leave a comment on our comment section. We will answer you. And don't forget to subscribe if you haven't subscribed. See you next time. Bye.